this tutorial, we will be talking about collection types. We will be covering arrays, sets, and dictionaries. These are the three Swift collection types. So, what is a collection type? Collection types are Swift types, and they are used to store collections of values. So please notice that by type I'm talking about type with capital T, so like integers, floats, doubles. Collection types are also types in Swift. The three primary collection types in Swift are arrays, sets, and dictionaries. Arrays are an ordered list of values which are all of the same type. The important thing is that they are ordered and they are of the same type. So for instance, we could be talking about arrays of integers which are put in a specific order on a list. Sets are lists of values of the same type, but the order in the case of sets is of no importance. So the elements of a set are not put in a specific order. Dictionaries are lists of key value pairs, and again, like the sets, elements of dictionaries do not follow a specific order. The values of the key value pair are all of the same type. The keys of the key value pair are again of the same type, but the types of value and values and keys are not necessarily the same. They can be different. The first topic is arrays. An array is a list of ordered values. An example is shown here. We have values which are put in this specific order: v0, v1, v2, v3, starting with v0, ending with v3. These are all of the same type. For instance, they're all integers or doubles or strings. In addition, we have a parameter called index, which is used to point at different positions in this array. The indexing starts with a value of 0 and it counts up by a value of 1. So 0 here points at the very first array element, and 3 points at the fourth array element. It should be noted that indexing starts from 0 in Swift, not from 1. Like other variables of a given type, variables and constants of an array type can be declared separately or can be declared and assigned simultaneously, and so forth. So here we are showing the very few examples of this. x1 here is declared to be a variable, and it's of type array of integers. This is a key word, capital A, RRAY, showing that this is an array. Within the angled brackets, we put the type, the data type of the elements of our array. So if the data type of the elements is integer, this is the way to show it. This is declaration alone. There is no assignment. An alternative to this representation, we could have a shorthand form of declaration, and we just put the type of the array elements within square brackets, and this indicates that x2 is a variable of type array of integers. Again, there is no assignment here. We could use the initializer format when we're using declaration. This is no longer declaration alone. Assignment is included in this. What this thing is saying is that x2 is a variable of type array of integers, but what this does, it returns an empty array, an array without any values in, and assign it to x2. So as I just mentioned earlier, this structure here declares a variable and assigns an empty array to it. So we've seen this initializer format in the previous tutorials when we were talking about strings, and in the case of strings, instead of just putting array of integers, we just use the keyword string here with the empty parentheses. So this is very similar. This is actually the same format as we used in the case of strings before. As a shorthand, we could use this format, which is the same as this, but with brackets in front of the array of integer type. And what this does is exactly the same as the previous case. The general cases of simultaneous declaration and assignment of arrays are shown by the following examples. I've divided this simultaneous declaration assignment cases into two groups. The first group shows the case where the type is decided by Swift through inference, and the second case shows the case where the type of a variable is explicitly mentioned in the declaration. So let's start with the explicit type. Here two examples are shown. First is just the way that arrays are generally indicated in Swift. So we have the keyword array followed by angled brackets, and inside we put the type of the elements of the array. So what the declaration here is showing is we are explicitly saying that x4 is of type array of integers, and the explicit type declaration is indicated by the colon here. Then we do the assignment, which says equal to the array of 1 or 2. This is very similar to all the simultaneous declaration and assignment cases we've seen before. The only thing is that instead of having a simple, say, integer or float type here, we are having the type array of integers. The shorthand for the case above is again shown here, and again we are having explicit type declaration where we are using colon here to show that x5 is a variable of type array of integers. Now going back to the inferred type, as we see here, we are not showing any colons, so we are not explicitly showing the type of x1. We are using this assignment operator, and we are assigning whatever is on the right of this equation sign to x1. So we don't say what type x1 is. So on the right hand side we have this thing, which is using the initializer format for arrays. So we are saying that we have an array of integer, and the right hand side returns an array of whose values are 1 or 2, as shown here. So Swift, by looking at what is generated on the right hand side, which is an array, determines that x1 is also an array, and because the elements of the array are integers, it determines that x1 is an array of integers. So that way the type of x1, which is array of integers, is determined. The shorthand for the above case is again shown here. The meaning is exactly the same as what I just discussed. The third way of doing this is, instead of using this arrangement or that arrangement, we can directly equate a variable to an array. So we do the assignment directly, and Swift knows by just looking at this that this is an array of integers. So automatically it knows that x3 is also array of integers. So again, Swift uses inference to determine the type of x3. So please note that the type of x3 is array of integers, it's not integers. An empty array is an array which contains no values, and it's indicated by two open and close square brackets, like so, with nothing inside, not even a space. And when we are doing assignments, we could use this notation to show that the value of an array of whatever type, in this case array of integers, is equal to the empty array. So that means x1 is an array of integers but contains no values. Again, it is important that x1 is an array of integers. In the future, if we are going to reassign a different value to x1, that different value should be an array of type integers. You can't assign a value of type double to x1. Here's an example of assignment separate from declaration. We just say x1 is equal to an array. Here I have assumed the declaration of x1 is already completed. Let's have a look at some typical array operations. If we wish to append a value to an array, we can use this .append arrangement. So what we do is, after declaring of our variable, which is of array of some type, we use the name of the variable followed by .append, which is a keyword. Inside brackets we put the value that we would like to append to the end of our array. It is important to note that this value must have the same type as the elements of the existing array. So the outcome of this would be this, that x will become 1, 2, 3. 3 is appended to what we had before here. We could also create an array of repeating values. The syntax to use is this: array followed by brackets. Inside brackets we have two keywords, repeating and count. So what this thing returns is an array which has 3 values, and all values are going to be equal to 5.1 as shown here. So whatever is returned is then assigned to X. We can concatenate arrays as well, the same way we concatenated strings in the past. So the examples that I'm showing here are X and Y, which are 2 arrays of integers. And I use the addition operator here to concatenate X and Y in that order: X first, Y next. Please remember that ordering is important in the case of arrays. So X plus Y would be different to Y plus X. So outcome of X plus Y would be 1, 2 first and 3, 4 next, all in one array as I'm showing here, and this, the outcome, will be assigned to our variable Z, and this is what would be the final outcome. We could also use the compound addition operator to add to concatenate an array with an existing array. So we are going to concatenate Z, which we formed here, with X, which is shown up here. So the outcome is going to be 1, 2 and 1, 2, 3, 4. Arrays could have repeating values, so this causes no problem. If you wish to know how many elements there are in a given array, we can use .count, and the way to do this is shown here. We have X, which is an array of strings whose elements are string 1 and string 2. Then Y is declared as a constant, which is equal, we are assigning the number of elements of X to Y here. So X.count will count the number of elements of X, which is 2, and assign that value to Y. So Y is equal to 2. We can also check whether an array is empty or not. To do that, we use this .isEmpty. So for an array constant X defined like so, we can use X, which is the name of the array, followed by .isEmpty. This is a keyword. This will return a boolean, false or true. If the array is empty, it returns true. If it is not, it returns false. And that value in this example is assigned to Y. In this particular case, Y will be false. We can read element of an array using subscripts. Subscript is another word for index. So with an array declared and defined by this line of code, we can access the element of array pointed at by this value, by this index 0, string 1. String 1 is then returned. So this is reading the element of array using subscripts. We could also change an array element by using subscripts. Again, we have the same array as we saw in the previous example. Now we wish to change the second element of this array from string 2 to string 3. So we use subscripts again here, X, square brackets, and an index. and the index is the index of the value we want to change. In this case it's 1. So by saying x square brackets 1 equals to string 3, we're changing this element from string 2 to string 3. New value of x is going to be this array, where string 2 is replaced by string 3. We can use dot sorted to sort elements of an array from small to large. So starting with an array x with these values, if we use x dot sorted, where again x is the name of our original array, dot sorted is the keyword, this would return the same array but ordered from the lowest value to highest, and that whatever that is returned in another array which is assigned to y. So this would be the outcome of this operation. We could change a range of elements of an array instead of doing it one by one. And to do that, we use the range notation as our range of subscripts. So in this case, we have an array x, which is defined like so, and we want to change the element, the second to and the third element to these new values. To do this, we use this arrangement, x square brackets, and then we range of the subscripts on the indices of interest, and then we change the values corresponding to this range of indices to these two values. So the outcome of this operation would be this, where x is equal to 1, 10, 11, 4, 5, where 10 and 11 replace 2 and 3, which are the array elements pointed at by this range. We could also insert and remove elements of arrays. To insert an element into an array, we use dot insert, and we use this notation, this arrangement here. So x, which is the name of our array, followed by dot insert. Inside parentheses, we have a keyword at, followed by colon. The first argument is going to be the value which we would like to insert into our array. It has to have the same type as the elements of the array. And at gives us the position or index of the array that we want to put this value in. So this thing is saying that insert 3 at the position pointed at by index 0, which is the first position. So as a result of this, what we will have is that 3 is inserted into here, and the remaining elements are pushed to the right. So we are having 3 followed by the old values of our array. To remove an element from an array, we use dot remove. So for this array, defined as 1, 2, 3, we use the name of the array followed by dot remove, the keyword, and inside parentheses we have at followed by colon. At, like the previous case, shows the address of the element of the array that we want to remove. In this case, the element pointed at by index 0. So what this does, it removes 1, which has the same index as 0. And after the removal, what happens is 2 and 3 are shifted to the left, and x will become 2 and 3, where 1 is removed. What this thing returns is the removed value. So in this case, 1 is removed and is assigned to y. When we are using remove, it is important to use a valid index. If we don't use a valid index, this will result in a runtime error. If we wish to remove the last element of an array, we use .removeLast. This arrangement here will return the removed value, which is assigned to y in this by this line of code. And after this line is completed, x will be the array of 1 and 2, with the last element 3 removed. Similarly, we could use .removefirst, and by doing this we can remove the first element of array. This will result in x to be equal to 2 and 3, where 1 is removed, and the return value of this is the actual removed element, which is assigned to y, and this is shown here. If we wish to remove all the elements of an array, we could use .removeall with parentheses in front of, and the outcome of this would be an empty array. So x will become equal to an empty array. If we wanted to remove a range of values of an array instead of just individual values, we can use the removesubrange as shown here. Within the parentheses in front of removesubrange, which is a keyword, we insert the desired range. In this particular case, I'm trying to remove the elements of array x whose indices are 1, 2, and 3. In other words, 2, 3, 4 here. So as a result of this, 2, 3, and 4 are removed, and we end up with 1 and 5 as the remaining elements of the array. We can iterate through the elements of an array by using a for in loop. In the example here, we have a variable x, which is an array of integers, and by using the for in loop shown here, what we're doing is we are extracting the elements of x and assigning those elements to this temporary variable called lm, and this variable can then be used within the body of the loop in the statements within the loop. If we wish to read both the index and value of individual elements of an array in an iterative process, we could use the for in loop and the keyword .enumerated. What this x.enumerated returns is a series of tuples. Each tuple contains the index and the value of individual elements of array in the correct order. And then the for in loop will take each tuple on a one-to-one basis and assign them to this sequence of variables, idx element. This is not a tuple, this is series of variables, temporary variables, which are only used within the for loop. So in the first run of this loop, the index and value of the first element are extracted and assigned to idx and element respectively. Then within the body of the loop, we can use those values as desired. Then we go to the next element of the array and take the index and value of that element and assign them to idx and element, lm here. And then we continue with the loop. And this process continues until we process the last element of our array. This concludes our discussion of arrays as one of the Swift collection types.